Welcome to the project presentation for DAMG 6210 for 2024 in Seattle. Team 1, are you ready to go?
Yeah, we're ready.
Okay, it's all yours.
Good morning. I am Supriya and I am here with my team members Yao, Manognya, and Jayan. And our project is Car Rental Service Database Design. So, first, I'll be talking about the project overview. Our task was to develop a robust relational database to support and enhance the operations of a car rental service. This database will manage critical operations, including customer information, vehicle inventory, rental agreements, and payments. So, the key features of our design includes streamlining rental processes for improved efficiency, enhancing customer service through accurate and timely information, enabling precise tracking of vehicle inventory and payments across multiple locations. The primary users of this system will be sales staff, managers at rental locations, and data scientists who will generate reports and analyze business performance. Next slide. So, coming to, uh, I'll go to next slide, missions and objectives. Thank you. So, our mission is to design an efficient database system for car rental services that will manage all information regarding customers, vehicle inventory, rental agreements, and payments, ultimately improving customer experience and operational efficiency. Our key objectives are data management, to efficiently manage data across all entities, retrieval to enable quick searches for smooth operations, status tracking to monitor bookings and payments effectively, and the fourth, last one, reporting to generate detailed reports on various aspects of the business. Now I'll hand over this presentation to my teammate Manognya.
Thanks, Supriya. So this is about the database design decisions. Let me start with the staff. This manages the rentals and customer interactions. Each staff member is linked to a store and can handle multiple rentals. This engages in rentals and provide reviews. Each customer has a membership status. Next one is car. This represents rental vehicles, tracking details such as status and location. Each car is associated with a store and linked to rentals. Next is car rental. This is a central entity recording all the rental details, including staff, car, customer, and store involvement. This connects to payments and reviews. The next one is payment. This captures financial transactions related to rentals, including the methods and status. This is linked to the car rental. Next one is store. This is about the physical location for rentals, where we have the staff and the vehicles. This is an integral for rental operations. Next one is car inventory. This is for tracking the vehicle availability and status for efficient allocation. The last one is reviews. This will handle, the customers can give their feedback on the rental experience. Next slide, please. This is the ERD. We have 12 entities. All the primary keys are auto-generated. Let me start with the entities, roles, and the relationships. First one is staff. This represents employee managing rentals uniquely identified by staff ID. Staff are linked to stores via store ID to track their locations. And the manager ID attributes, this enables self-referencing to track reporting hierarchies. There is self-referencing between manage ID and staff ID here. Next one is customer. This stores customer information uniquely identified by customer ID. This is linked to membership status through membership status ID, enabling benefits. The next one is car. This entity details about rental vehicles, and this is identified by car ID. This is linked to car status via car status ID to indicate the availability or maintenance status. and to store entity via store ID to track the location. Next is car status. This table is about describing the status of car, as in it's available or under maintenance or is it booked. This is identified by car status ID to ensure that we only the good condition cars are rented. Next one is store. This represents the rental service locations identified by store ID connected to cars entity to manage the inventory and to staff entity for the employee assignment. The next one is membership status. This defines the customer membership levels identified by membership status ID. The membership levels, there are two for our database. One is permanent and one is temporary. The permanent people don't have start date and end date, but the temporary people do have that. These are linked to customer to provide the benefits. The next one is car rental. This is the central entity recording all the rental transactions identified by car rental ID. This is linked to customer ID to know the renter information. Next, it is linked to car ID to know the rented car. Next, to staff ID to know which staff is facilitated. Next one is store ID. This is to know the rental location. Car rental status ID to know the rental progress, and the last one is car rental review ID to know the feedback from the customer. Next one is payment. This manages the rental payments. This is associated with payment ID. This is linked to car rental ID to know the associated rental, payment method ID to know how the payment is made, and payment status ID to understand how the payment, the completion status, is it completed or not. Here, the payment method and payment status tables could be put in payment entity itself, but we are using the separate tables to just make it easier to manage. Next one is car rental status. This tracks the status of rental identified by car rental status ID to maintain the rental life cycle transparency. Even here, the car status and car rental status tables can be put in car rental itself, but we are putting it as different and separate entities just to make it easier to manage. The next one is method. This is to list the payment methods we have, like debit card, credit card, or gift voucher. This is identified by payment method ID linked to a payment entity for transaction details. Payment status is to track the payment status, whether it's paid or pending or whatever, identified by payment status ID, just to ensure the financial clarity. And the last one is car rental review. This is to record the customer feedback on rental identified by the car rental review ID. Now from here, my teammate Yavo will continue.
Hey there. Thanks, Mano, for explaining our ERD, and that's really helpful because those are just basic informations for me to explain some other database designs in our project. The first one is a computed column here. So you see we created a function called project calculate total amount, which is a straightforward function name. It just adds the actual payment amount and discount payment amount to output total amount. So where we're gonna use it. So if we go back to ERD, we will see that in payment, there's total amount, there's actual amount, payment amount, and discount amount. How do those fields work is that some customers, they might get coupons for their car rental, and the coupon will be regarded as a discount amount. For example, he has a $20 coupon, and then his actual payment for that car rental is $180. So the total amount will be $200. However, in our database, we don't have to, manually calculate the total amount each time by manually adding actual payment account and the discount amount. It's a computed column in this table. As you see here, it's total amount as project calculate total amount function, which is adding actual payment amount and discount amount. Then every time a payment record is inserted, the total amount will be automatically generated. And you see here in the end of this total amount, here's a persisted. That means the total amount data or the value will be physically stored into the database, into the storage after the actual payment amount and discount amount are inserted. If we don't add this, then this value will be on the fly. It will be calculated every time we retrieve the data from this table. The next one is table level check constraint. So we added a constraint, a table level constraint to car rental to check whether the total amount of the car rental is exactly the sum of total amount of each payment of this car rental. Let's go back to ERD. So here you see in car rental, there's a total amount, but payment, there's also a total amount. However, one car rental can have multiple payments. So this total amount should be the sum of each payment of this car rental's total amount. Yeah. And how this function works is that we will return a bit, and if it returns 1, then we've got a trouble because it has to be 0. So how do we check whether it is 1 or 0? We have a SQL here to count if there's any car rental transaction which has been completed, but the total amount of this car rental is not equal to the sum of total amount of each payment of this rental. So if there's any, the count will be at least 1, right? It has to be larger than 0. If it's larger than 0, then it returns 1. If it returns 1, then the constraint will give a warning or something, a warning, and people will know. Then we have created 3 SQL views to generate some valuable report for in the future for people, for business analysts to analyze. The first one is staff performance summary. So in this view, we will return each staff's total rental handled, total number of car rentals handled by each of the staff member, and also the total revenue generated from rentals managed by each staff member. And I set a time here, so it will only count all the car rentals in last 30 days. The SQL view 2, almost same, but it's in store level. So instead of having each staff's performance, we have each store's performance. Same here. Store ID, store name, location of the store, and total car rentals handled by each store, and total revenue generated by rentals from each store. Still, we have 30 days limitation. The third view will be talking about the popularity of each car make. So we want to know which cars, whether the luxury car or some basic car or a sedan or SUV is more popular among the customers. So we will have the make, car make, total rentals, and total revenue as the result of this view. Also, yes, it has a 30 days limitation here. And all of these views we can order the data by total number of rentals or total number of revenue to see which car is the most popular, which store has the most revenue, or which stuff is the the number one stuff. And I think those are really helpful to manage the stores, the stuffs, and the cars in the future. Thanks. Next part is the visualization.
Hello, thanks for the SQL views of our database, and I will show you the visualization by Power BI. Why we choose Power BI to connect with the Beaver, we ensuring smooth and reliable connection to our car rental database for the real-time analysis and visualizations. Power BI helped us turn raw data into clear and useful insights. So with its flexible and strong data modeling features, Power BI allowed us to connect multiple tables and find important trends for decision makings. And below are 4 pictures for visualizations. These cover key areas like revenue trends, staff performances, membership status, car popularities, and the geographic demand. By breaking down the data into actionable insights, and they support smarter planning and better decision making across the business. So let's show the first picture. The first chart shows the sum of actual payment amount by city and store ID, and making it easy to see which cities are bringing in the most revenue, like Seattle, Tacoma, and Belleville. It gives us a clear picture of where demand is highest and helping the team make smarter decisions about where to focus resources or even consider expanding in the future. However, this chart does not display the specific source ID directly. However, but in Power BI, you can just hover over the blue, orange, or other segments so that you can see the corresponding source IDs. These interactive features ensures all necessary details are accessible. Now let's look at the second picture. The second visualization is the sum of actual payment amount by day. It is giving a clear picture of of how revenue changes day by day, so that managers can easily spot peak days when revenue is higher and the quieter days with less activities. These help managers plan better and making sure resources are allocated efficiently when they are during the busy time and on busy time. This also identifying patterns in daily fluctuations. Now let's look at the third picture. The third visualization chart shows is the sum of actual payment amount by staff and store ID. It is highlighting the individual staff contributions to revenue within their respective stores. It helps identify high performance employees who drive revenues growth and assist managers in assessing workload distributions. So by understanding these patterns, managers can make informed decisions to optimize staff performances and address areas for improvements. So we can see which staff and which store ID have the better performance for this chart. And for the fourth chart is the sum of actual payment amount by membership status descriptions. And this picture showcasing how different membership statures contribute to revenues. It is highlights the top performing memberships, such as the top one is the activities basic plan. While identifying the underperforming ones, this insight can guide the strategies by the managers to enhance popular plans and promote and also promote the less utilized ones. Finally, it can drive better membership engagement and increase our car rental systems revenue. So with these 4 pictures visualizations, we can transform the raw data into the meaningful visualization that address practical operations areas. These insights empower managers to optimize resource allocations and improve customer satisfaction, driving long-term business growth and also ensuring the car rental service remains competitive and efficient. So here is the visualization. And now we have Supriya to the conclusion.
Thank you, Jaya. As we conclude our presentation on the car rental service database design, I would like to summarize the highlights of our project. First, we developed a robust database to manage customers' vehicle inventory, rentals, and payments. Then, we streamlined the processes for better efficiency and enhanced customer experience. We presented an entity relationship diagram showcasing relationships between key entities like staff, customers, cars, and rental agreements. We ensured data integrity with table level constraints and implemented a payment computation function. We created 3 SQL views offering actionable insights into staff performance, store efficiency, and car popularity. We delivered visualizations that highlight revenue trends, location based performance, and membership impact. So, I would like to say that we focus primarily on optimized operations, strategic growth, enhanced customer experience, and actionable insights. Our design meets current needs and provides a scalable foundation for future growth, empowering staff, managers, and customers alike. Thank you for your attention. We are happy to address any questions. Any
Hi.
questions?
Okay, go ahead, please. Oh yeah. Can you go to the ERD slide, please?
Here we go.
Okay. Yeah, I find that you have a solid line connecting to itself in the staff table.
Yeah, it is.
I wondering what does this self-referencing relationship represent?
So for example, you can just reference manager ID to staff ID. So you can join staff table to staff table by connecting staff ID equals to manager ID. Then you will see what who you can see this staff's manager, who the staff's manager is.
Okay. So
Did I answer your question?
yeah, I think do you mean that you can see what's current staff the manager is by self-joined, right?
Yeah. Let me give you an example that will help. So for example, I'm a staff. My name is Yao. I have staff ID 1, and my manager ID is 2. And here's another staff called Shu Yao, right?
Yeah.
Her staff ID is 2, and her manager ID is 3. So my staff ID is 1, and I have a manager whose staff ID is 2. So you will be my manager. Here, my manager will be 2. So when I join staff with staff by joining staff ID equals to manager ID, manager ID equals to staff ID. So the result of that SQL output will show that you are my manager. Because my manager ID is your staff ID.
Yes. Okay.
Yeah,
Yeah,
did I
thank you
answer your
so much.
question?
Thank
Okay.
you. Oh, but why don't you use extra table like the manager
Because manager, it's essentially a staff. Even you are a CEO, you are a staff of the company. And also self-referencing is kind of an easy way, and also a common way to um to how do I say that? To manage the manager hierarchy in the
Okay.
table. Yeah.
Okay, thank you.
Yeah. Thanks for asking the question.
Just a quick comment. If we have a separate manager table, then we will have to duplicate data for the manager employees because managers are also employees. So I think it's a more elegant way, a better way to track the reporting relationships using the self-referencing, like what Team One did. Yeah, great question.
Thank you,
Yeah.
Prophet.
Thank you for the question. Do you have some other questions, group 2?
Yeah, I also have another question.
Yeah.
It's the same page. So as you can see,
With
in the ERD, the car entity and car status entity. And I understand, yeah, I understand that a car can have many like car status, but how does car status can have zero or many relationship with car entity? So from my understanding, car can only have like
yeah, car can sorry, please go ahead.
Yeah. To my understanding, I think a car can have many status, but as long as a car has a status, that has to be linked to at least one car entity, right? So yeah,
I think you understood this crossfoot in a reversed way. Please correct me if I'm wrong. So here it means that one car can only have one car status, and it must have a car status. And here it means that one car status can be zero to many cars have. So, for example, the car status ID, they are completed, not yet finished, or say canceled, or say destroyed. This destroyed is not used by any car, because no car is destroyed. So that's why we put an optional circle here. So I think you understood this notation in a reverse way. So Simon, am I right?
Yes.
So that means a car can have many car status.
No, car can only have exactly one car status. Yeah. And one car status can
have zero or many cars entity.
Yeah, can be had by zero to many cars.
Oh, okay.
Yeah.
A car status can be had by zero or many cars. Yeah, that is my question. So how could a car status be had by zero or many cars?
I mean, if no car is destroyed, then the car status won't be there. There's no car with the car status destroyed, right? So the destroy status in this car status is not used by any of the car. However, good condition in this car status is used by a lot of car because a lot of car is in good condition. So it's zero to many relationship here.
Yeah, I think another way to look at this design is, I think the fundamental question is, are we just going to track the current status of a car, or are we going to track the status history of a car, right?
Oh, yeah.
So I think that's where the confusion might have originated.
Oh, yeah,
You see what I'm
you're
saying? Yeah.
you're right.
So
Yeah.
but I think Team One made the decision to only keep the
The
current
current.
status. Yeah.
Mm. Yeah, that answers my question. Thank you.
Yeah, thanks. Great. Any other questions?
Just one curiosity. I noticed that all the entity except the staff, it connect with staff self use the solid line. I noted the other entities all use the dotted lines. Have you think about use the like a composite like a compound primary key, and maybe you can change the dotted line to the solid line? Just
You
wonder.
mean car rental?
Yes, several key entities. Maybe
Yeah, I get what
the
you mean.
composite.
So
Yeah.
all of those 6 foreign keys, they can be used as one compound primary key in the car rental table, right?
Yes.
But yeah, that's also an option. But that's kind of like a personal preference. When my group and I were designing the whole database, we decided to just have primary key, unique primary key for each table. There's no specific reason. Just prefer to
Correct.
doing that way.
Yeah, I understand.
Yeah.
Thank you.
Yeah, thanks.
I think our team doesn't have a question anymore.
Okay. Team One, could you go to your computed current?
Yeah, here we go.
Okay. I think it's very interesting. You included the option persisted.
Yeah.
And in industry, very often we just indexed that current, obviously to physically store the computed value in the database. I think to create an index is a very common option, but this is also a good option, persisted. But for either option, for both options, the requirement is the computed value must be deterministic. So if your value, the computed value is not deterministic, then we cannot use persisted, and we cannot index the computed column either. And then to determine whether a value is a computed value, a computed column, another way to say it, to determine whether the computed column is deterministic or not, there's a SQL function. We just run the column, the formula or the function through the SQL function, system function, and then it will tell us whether it's deterministic or not. Great work, yeah.
Okay. Sure. I've got it.
Do we have any other comment or question for Team One? Anyone else? Okay, great work and great presentation. Thank you, Team One.
Thank you so much, everyone, and Simon.
Sure.
Just everyone.
Thank
Sorry.
you.
Yeah,
Thank you.
Okay. Now let's welcome Team Two.
Okay, Professor. I will be sharing screen for
Okay, so Justin, you will be running the slides, right?
Yes, I will be running the slide.
Okay, yeah, go ahead, please.
No problem. Okay, I'll start the presentation now. So hi everyone. Hello professors. Today we'll be presenting our database, the Alumni Management System for Northeastern University. The group member including me, Shu Yao, Shu Xing, and Mukaila. So the purpose of our database aims to provide a comprehensive information about alumni that graduated from Northeastern University. So it allows users to keep track of the students' or alumni's academic records, the employment history while they're inside in the university or after they graduated from the university, as well as their academic achievements, and as well as the engagement they had with the university, specifically their donation records. So this is our ERD. As you can see, they've been identified by 3 colors. On the top is the alumni themselves, as well as the donation records and academic recognition, which is essentially their connection with the university and their engagement with the institution. And at the bottom left, the blue entities are the employment-related entities that has employment, job, company, and city, as well as a connecting entity called company city. And there on the right, the red entities are enrollment entities, which includes the college, major, degree, and campus information about each student's enrollment. An alumni or student can have multiple enrollments, which is not typical, but that could happen for students who have gapped or who have skipped years in the university. And there are many different relationships, identifying and non-identifying relationship between each entities, and we'll dive deeper into that separately next.
Okay. Hi, next I'm going to talk about alumni entity, which is our entity for collect information about the alumni at Northeastern University. This entity has 4 attributes, which is ID, first name, last name, and the status. Next, please. Yes, here is the data we insert to our database and select to show to you guys here. And next, please. Yeah, next is our donation records entity. This entity, we create a composite primary key, contains donation ID and your ID. And the function of this table is to track the alumni information about the donation. Yes, here is the data we have inserted to our database. And next is about academic recognition, which also we create a composite primary keys, which is recognition ID and your ID. And the next is our data insert to our database.
Hi everyone. Next, I will be introducing 5 key tables that are part of our alumni management database, designed to track alumni employment and provide insights into their career journeys. This table includes employment, job, company, city, and company city. Let's dive into each table to understand their purpose and relationships. The first is employment table. This employment table serves as a critical entity in our database. It records where alumni work after their graduation, which give us an insight into how well their education aligns with the career outcomes. This table tracks employment details such as the alumni's ID, you can see it's NUID, and job ID start date and end date. It has a one-to-one relationship with the job table, where each record reflects one specific job. However, alumni can have multiple employment records, which also allowing us to track career changes of multiple roles over time. This table directly ties to alumni outcomes and is a valuable source of data for us to show the employment by major or college on our alumni management database. Next, please. Thanks. This is job table. This job table provides detailed information about the role alumni hold after their graduation. It includes fields like job title, job description, and start date to capture the essential details about each position. For example, the different roles such as software engineer, data analyst, and project manager, along with their respective responsibility. So this table will allow us tracking of alumni career progression and the types of roles they take up in various industries. Next, please. Thanks. This is the company table. The company table stores information about the organization where alumni are employed. It includes fields like a company ID and a company name to identify companies such as different company name. This table plays a role in connecting alumni job to specific companies, enabling our insights into where alumni are working and the industry they are contributing to. Next, please. Thanks. Next, yeah. This is our study table. The study table captures the geographic information about the locations associated with companies and alumni employment. It includes fields like city ID, city name, state, and country, allowing identification and tracking of alumni location. Yes. So this table support detailed analysis of alumni employment trends by region and help link company to specific cities. Next, please. The last one is company city. This company city acts as an association or bridge table that connects companies with their specific locations. It established a many-to-one relationship with both the company and the city table. Because a company can have multiple locations in different cities, and a city can host multiple companies. So this table also indirectly connects with the job table, allowing us to analyze our alumni employment trends across various industry and regions. Thanks.
Okay. I'm going to talk about enrollment. Enrollment is basically one of the central part of this work because enrollment has a lot of connection with college, major, degree, and campus, right? So without enrollment, this thing can never be, they can never come into play. So basically, enrollment kind of indicates the past record of alumni and they maintain the record of their graduation and multiple entries of the alumni. So in enrollment, we have student ID, that is a primary and foreign key that's taken from other, and we have alumnus campus ID, that's a foreign key, center primary key, and we have college ID, we have major ID and degree ID, and we have graduation ID. All those things are, so for this enrollment, it encompasses a lot of things that alumni have to connect alumni with different factors like college, major, degree, and campus. So it makes one of the central parts here. So from this chart, you can see the student ID, which the ID basically, if you think of ID, it basically means like you create an email or you create an account in one of the websites for or anywhere, Yahoo ID or that. So you have a username. So that username belongs to you forever. Nobody can take that username. So nobody, this campus NU ID is an ID that we use to allocate every alumni in enrollment, their past the enrollment. Yeah. And we have campus ID, which has the same significance, and we have college ID, we have major ID, degree ID, and enrollment date and graduation date for both undergrad and graduate in this sense. Yeah, can you move on, please? So we have campus. Campus basically captures physical location, like geographic location of the where the course have been taken or where the program has been taken, right? So each campus serves as distinct venue for academic major programs like understanding the campus context, include tracking and alumni enrollment. So campus basically has it has one and one only relationship with enrollment. So one campus can only one alumni from one campus can only enroll in one-on-one courses, right? So and also the enrollment has the same relationship with campus. So in campus we have campus ID, which is a primary key in campus. We have city ID, which is the foreign key taken out from the. So it serves very important because it demonstrates where the campus is located in this sense. Can you move on, please? So this is a campus ID and this what the entity captures. So you have campus IDs, the numbers, the campus name, and the city ID. So this basically make it like give the identity of the value of that campus that we have, and that can be traced back, and alumni can trace back to it, can trace back to find alumni's record and that. So we have Boston campus, we have Seattle campus, we have Silicon, Portland campus, Charlotte, Vancouver, and Toronto campus, and many others that we have, and they have their IDs and everything that make for the alumni. Move on, please. So we have college now, college which is a very important entity of the university. It serves as an important component for organizing and categorizing alumni based on their respective colleges through tracking of enrollment, right? So college in this sense has one-to-many relationship enrollment. So one college can have different one college alumni can have different enrollment. They can enroll in different courses in this sense. So in this sense, college has like it has college ID and college name, but the primary key is college ID that captures the identity of the college for alumni. And it has like additionally it has an entity that relationship with major cities, and meaning that both the major and college entities can exist independently of each other. Can you go ahead? Can you move on? Thank you. So this entity captures the college ID and college names, where we have like the ID which make like it captures the ID of the college. Every college has the ID number that they can use to locate. Even for example, if alumni complete or they transfer to different colleges, then we can have the ID to track their information there. So we have College of Engineering, we have College of Arts, Art, Media and Design. We have College of Science and School of Law, and many other colleges. These are few that we capture in this work. Can you move on, please? Now we have majors, which are very another essential part of this work. Major encompass the database that represent various academic fields offered by the university. Maybe let's say Northeastern University. That's what we are working on basically. It allows a very good understanding of alumni background and area of specialization. And most of this major is related you have a very strong relation with enrollment, because one major can have one or many enrollments, like enrollment. Most of student alumni can enroll in one or many courses in that major. And the basic thing is that this major has the major ID, which is the primary key, and it has a college ID, which is a foreign key, and the major name. And at the same time, this major has a link with degree. So one major can have like one alumni from, or one major can have one or many degree. So can you move on, please? So this is the data that we captured for major, which basically has major ID and the major name and major the college ID. So where basically the major ID signifies the ID of that major. For example, take the name of the major is information system. So you have the ID data architecture, you have also ID, and have a college ID where it shows that where the geographical location of that where that course or where that program has been taken. So the college ID represent that. And you have other one, computer science and that. Oh, it's okay, let's move on. Okay. Now we have degree, which is also represents very important aspect of this. Degree is basically the academic recognition given to or prize given to student after their graduation completion of the course that they did. So degree ID basically serves as a primary key, uniquely identify the degree. It has an attribute of a degree has an attribute of it might be bachelor degree or master's degree or PhD or certificate. And this attribute include the specific program that the alumni has taken. So some of them can be computer science, information system, in data science, economics, and other. And this structure clarifies the educational path taken by alumni and connect their enrollment to their choosing majors, right? So this degree has kind of link with major and the same time enrollment. So one degree can have one alumni with a degree can enroll in one or many courses, right? At the same time, one degree, somebody having degree can only have one only major for alumni. So this is another important thing. So it's also related. Okay. So degree in this sense has degree ID, because every degree has its ID. It has a degree name like Masters of Science Economics or Masters of Science Information or something like that. And it has a degree type. It is graduate degree or some other graduate degree certificate, and they have a degree ID. So that will show that can help to backtrack or follow the track, academic track of the course and the alumni. Yeah, so can you move forward, please? Okay.
Okay, I'll cover the function part. Here we created a function called check employment dates, which take a start and end date as an input and returns a bit. And this function checks whether the start date is actually earlier than the end date. So when user insert data into our employment records, so they automatically check if the end date is later than the start date. If not, that would return 0, which means invalid. If yes, that would return 1, which represents that it's valid. So this check prevents users mistakenly inputs data that has employment data that has the wrong end date and start date. And this is our computed columns. It's pretty straightforward and easy. We have the first name and last name of these alumni, and we computed the full name as the combination of the first name and last name with the space in between. And this is our view. The first view is the alumni employment details, which includes all the data about alumni and their campus, their job, and their company, as well as the employment data, whether they have an employment end date or not. So if this data has no employment end date, that means this person with alumni ID are still working at this specific company at these specific locations. As you can see, we keep track of the alumni ID, and we take the alumni name from the alumni ID, and we join them with the campus and their employment records to get this data. Our next view is the alumni achievement and donations. Those are their engagement with the university. So we join the alumni with their academic recognition as well as their donation records to extract this data. We can have the achievement issuing date for these academic achievements. And we also have the donation date and donation amount, as well as the donation purpose of each student's donations. And the third one is the company city details. This is an extra view that we created to showcase the company city entities. For each city and each company, we have a combination of company city connecting entities, so that that can help us to keep track of the each city inside the company and each company inside each city. And we have the company city and company ID and city ID to keep track of this information. Next, we'll be introducing our views and reports and visualizations.
Yeah, about the reports and the visualizations, I choose to use Tableau because I use the MacBook. And in the first example, I create the table. This view name is quarterly donation statistic. It can display the donation amount contributed by each individual in each quarter. I use the source table from alumni table and donation record table to select the attributes to build the column and the row and build this visualization. And about the example, I select purple part and show the information. Shuxin donates $1,200 in quarter 2. And next, please. And about the second example, I create the visualization named country, campus, and the college major distribution chart. And I get the source data from campus table, city table, college table, major table, and the enrollment tables. If you know the details about our system, the database system, you can notice that I didn't show the attributes related in enrollment table, but I still need to connect it because I need to connect campus table and the college tables through the enrollment table. And from this visualization, you can read the data relationships, connect campuses to cities and countries, and link the colleges and the majors offered at each campus. And here I collect one spot, shows the information about Vancouver campus, the College of Computer Science, located in Canada, and the major name is Computer Science. Thank you. Yeah, here is our presentation. Thank you so much.
Yep, that pretty much summarized our presentation for our database. Does anyone have any questions?
I think I'll go with the first question. Your slide, you have a lot of slides here, so I don't know which one I'm going to looking for. So can you scroll up first? It might be related to, I don't know, the employment.
Here?
Yeah, can you scroll down one more? Yeah. So here, by the way, what's a primary key in this table?
Oh, employment, the primary key are the job ID and NUID.
Okay. So firstly, can you go back to that page?
Yes.
I don't know if this question is stupid because I have no idea if it's even a correct question. So,
Don't worry about
for
it.
example, one NUID is related to alumni, right? One alumni.
Yes.
What if he or she changes the job? What are you gonna do?
That way we would have, that means, so this employment, think of it as employment history. So one can have a zero or many relationship between the alumni and the employments. So if an alumni changes the job, that would be assigned a new job ID to this new ID. That means alumni can have multiple job ID that represents the employment history of this specific alumni. So if this alumni changes a job, that would means he or she would be assigned a new job ID with new start date and end date. Yeah, so think of it as not not as like one specific employment attached to one person. Think of it as an employment history of an alumni. Yeah.
Okay, so you go to the next page. So as I understand, you will never delete any of the recording from this table. All the record will only be added.
Yes.
Okay, and
that's the purpose.
Sorry?
Yeah, that's the purpose of the employment history. We try to keep
For
track
example,
of
are those sample data valid data or just some random data? Because if you see row number 2 and row number 5, you have NUID, which is 2, but have the different job ID. Oh, yeah, 2 and 5. And they both have a start date but no end date. What does it mean? Does it mean that he or she's doing the 2 jobs at the same time?
Yes. So this basically means, let me go ahead and so here, that means, so here you can see, oh, the data is actually not quite correct, but what it means here is I'm actually, I think the data is a little bit off. What I'm trying to do here is I'm trying to have, because I'm currently a TA at Northeastern University, but I'm also part-timing at another startup. So that means I can have 2 employments at the same time, even though they have different start dates, but none of this job has ended. So that's the purpose of this data that you see.
Okay. So if there is an end date for any of the record, then it means that this job is ended.
Yes. Yes.
Okay. Okay, that sounds fair to me.
I hope that answers your question. Yeah.
It answers.
Yeah. Thank you. Yeah, that's a really good question. Thank you so much.
Thanks.
Any other question?
Oh, by the way, just one more thing. So usually it will help if you add, for example, a current, I don't know, current indicator or something in this table. It will be better. So you will see
current
which
status of the job, like whether this employment ended or not, right?
Yeah, things like that. Because if you want to know who's currently in employment, you have to fetch out the, I don't know, end date or things like that.
Well, that's really good advice. But currently, what I'm gonna do is, when I was extracting data, I would just check if the end date is null. So if that's null, that means, but if the start date is not null, but the end date is null, that means that the person is still like working at a specific location right now. Yeah.
Okay, I see. Yeah, because a person can do multiple jobs at the same time.
Yes.
I didn't know that. Anyways, thanks a lot.
Yeah, that's my personal experience right now.
Okay.
Yep.
Yeah.
Any other questions?
I don't know. Supriya, Mano, Giant, do you guys have any questions?
Simon,
I
did
am
you have
good.
any? Oh, okay. Please go ahead. Yeah.
I said I'm good.
Okay.
Yeah. So, Team 2, could you, go maybe just roll up one slide. Go up. Yeah. Okay. Here. Here. This one. Yeah. So, you did pretty well on emphasizing each and every entities, or at least you emphasize one entity at a time. It's just an input for optimization. You also have description, and there is a lot of text for describing this this entity. So when we do the presentation, usually the audience will follow your presentation flow. If there's too much text to read, then it could be very confusing. Also, probably if you have summarized description such as bullets, then it's going to make it much easier for the presenter. So just one one input for optimization.
Okay.
Yeah, no problem. Yeah, that's a really good advice. Thank you, Simon. Thank you. Yeah.
Great work. Yeah, great work and the presentation from Team 2. Any other comment or question for Team 2?
Yeah, I have one comment here, but it's just my personal perspective. So, like you guys spend a lot of time, like to maybe 70% of time describe each tables,
Yes.
each table, and as an audience, that's kind of tedious to me because I'm just listening to what columns you have in this table and what sample data are there. Yeah, and it lasted for a long time, but that's just my personal perspective.
Oh yeah, yeah, we will try to be like include as much details to help you guys understanding the each entities as much as possible.
Okay.
I know, yeah,
Okay.
I think our group went a little bit further on that. But yeah, the purpose was solely to help you guys understand the purpose of each entity. And
Okay. Yeah.
Yeah, we'll try to
But you know, the overall quality of this presentation is good. Wonderful.
Yeah. Thank you so much.
Yeah.
I think this is a great discussion.
Mm.
And usually when we present our ERD, our database design, we tend to focus on some highlights. For example, you have a group of entities regarding a specific feature, then you will probably include several entities, 2, 3, and then you will have some bullets. And we don't really have to go through all entities in our design. But
Okay.
you know, if some highlights will make it a lot more attractive to your audience, and then probably can keep your audience more focused on what you want to showcase.
Yeah. No problem.
Yeah.
Yeah.
A great discussion. Yeah.
Yeah. Thank you, Simon. Thank you.
Sure.
Yeah.
Of course.
No worries.
Any other question or comment for Team 2? Thank you, Team 2. Great work.
Thank you guys for listening.
Great presentation.
Really appreciate it.
Thank you.
Yeah. This is the end of our presentation. I was impressed with your accomplishment in DAMG 6210. Kudos to everyone.
Thank you, Simon.
Thank you.
Simon. Thank you,
Thank you,
Simon.
Professor.
Thanks.
Thank you.